Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, students. Welcome to chemistry class. So today we are going to learn about chemical elements, especially noble gases. Let's start studying the material. All right, we come to the introduction of noble gas. So noble gas, any of the 7 chemical elements that make up group 18 of the periodic table. The elements are helium, neon, argon, krypton, xenon, and radon, and oganesson. The noble gases are colorless, odorless, tasteless, non-flammable gases. They traditionally have been labeled group 0 in the periodic table because for decades after their discovery, it was believed that they could not bond to other atoms. That is, that their atoms could not combine with those of other elements to form chemical compounds. Their electronic structures and the finding that some of them do indeed form compounds has led to the more appropriate destination, group 18. All right, as you can see in this table periodic, this is the noble gas in the actin groups, helium, neon, argon, krypton, xenon, radon, and August neon. So, all right. For more understanding about the noble gases, let's watch the, the video about noble gases. Please pay attention to the video.
What do party balloons, neon signs, and certain light bulbs have in common? They are all filled with a noble gas. In this lesson, we will learn about the noble gases, their properties, and their uses. The noble gases are the group 18 elements: helium, neon, argon, krypton, xenon, and radon. These elements are notable for having a full valence shell of electrons. Helium has 2 valence electrons, whereas the other noble gases each have 8 valence electrons. The noble gases all have full valence shells, which makes them very stable elements. In fact, they are so stable that, in the past, chemists thought that they could not react with other elements, which is why they were called the inert or unreactive gases. However, we know today that some noble gases can indeed react to form some compounds, which is why today this group of elements is called the noble gases instead. All of the noble gases are colorless and monatomic, meaning that they exist as single atoms. Moving down the group, the number of electron shells increases by 1 shell. Hence, the further down the group, the bigger the atom. The size of the atom also affects its boiling point. These boiling points increase because intermolecular forces between larger atoms with more electrons are greater than that between smaller atoms with fewer electrons. Also, moving down, the density of the gases increases because larger atoms take up more space in a set volume. Since they are very stable and are hardly reactive, as well as their individual characteristics, the noble gases have many practical, real-life applications. One you might already know is helium, used to fill party balloons. Since it is less dense than air, these balloons float. And because of this property, helium is also used to fill airships. There are actually many interesting uses in industry. Krypton and xenon are used in some types of lasers and in flat panel display manufacturing. Since the 1990s, xenon is being used increasingly for car headlights to increase road safety. Xenon lamps produce a very bright light and increase contrasts and color vision. Although it is very inert, when an electrical current is passed through neon, it emits a bright orange light. Light bulbs are filled with argon. Unlike air, it will not react with the tungsten filament. Noble gases are also applied in medicine. Xenon is an effective natural anesthetic. It helps doctors maintain the patient's blood pressure and heart rate during operations and has particularly few side effects. Meanwhile, radon is highly radioactive, which is a characteristic that has been put to use in radiotherapy in attempts to cure cancer. These are the traditional uses of noble gases, but it even goes beyond that. Krypton is sometimes used as a filler in double glazing. Set between two glass panels, krypton will offer very good insulation because it has a lower thermal conductivity than the molecules making up the air. And it doesn't stop. In the space industry, xenon is used as a propellant that helps us steer satellites on their orbital paths. Its mass ensures that we can put the satellite in movement. So now you know the basics of noble gases. The group 18 elements, also known as group 0. Their stability is one of their main characteristics, allowing for many real-life applications.
Right, after that, let's talk about general properties of the group. Noble gases have uses that are derived from their other chemical properties. The very low boiling points and melting points of the noble gases make them useful in the study of matter at extremely low temperatures. The low solubility of helium in fluids leads to its admixture with oxygen for breathing by deep sea divers. Because helium does not dissolve in the blood, it does not form bubbles upon decompression as nitrogen does, leading to the condition known as decompression sickness or the bends. Xenon has been used as an anesthetic, although it is costly. It is non-flammable and readily eliminated from the body. Radon is highly radioactive. Its only uses have been those that exploit this property, example, radiation therapy. And then oganesson is also radioactive, but since only a few atoms of this element have thus far been observed, its cycle and chemical properties cannot be documented. And then only krypton, xenon, and radon are known to form stable compounds. The compounds of these noble gases are powerful oxidizing agents, substances that tend to remove electrons from other and have potential value as reagents in the synthesis of other chemical compounds. Right. Each noble gas element is situated in the periodic table between an element of the most electronegative group. The halogen elements group 17, the atoms of which add electrons to achieve the octet and thereby become negative ions. And an element of the most electropositive group, the alkali metals group 1, the atoms of which lose electrons to become positive ions. So several important use of the noble gases depend on their reluctance to react chemically. Their indifference toward oxygen, for example, confers a turn on flammability upon noble gases. Although helium is not quite as buoyant as hydrogen, its incombustibility makes it a saber-lifting gas for lighter than aircraft. The noble gases, most often helium and argon, the least expensive, are used to provide chemically unreactive environments for such operation as cutting, welding, and refining of metals such as aluminum, atmospheric oxygen, and in some cases, nitrogen or carbon dioxide would react with the hot metal. All right, there are similar properties of noble gas. Noble gases share many similar properties, including the first one, a full outer shell of electrons. Helium has 2 electrons in its outer shell, and the rest have 8 electrons. Because of their full outer shells, they are very inert and unstable. This means they don't tend to react with other elements to form compounds. And then there are gases under standard condition. They are colorless and odorless. Their melting and boiling points are close together, giving them a very narrow liquid range. All right, student. Thank you for your attention. So that's all about our material today. See you on the next meeting. Assalamualaikum warahmatullahi wabarakatuh and good afternoon.